My name is Ranganatha Mukusuma. I'm one of the product managers at the Cloud Data Quality. Today, I'm going to show you how the Cloud Data Quality works and also show you how it is actually integrated with the data governance. Let me start backwards with bit, like based on the life cycle that Cheryl has shown in the slides, where we have data quality life cycle, design, define, and then apply, and also the monitor. The screen that I'm on is actually the scorecard, which is for the monitoring phase, where you can see all the information about the current data quality scorecards for a given data set. I have a scorecard already defined and then ran the scorecards for the customer sales. As you can see here, all the scores for all the data quality dimensions, be it validity, completeness, consistency, and accuracy. You can see the score information. How this score actually came is all using the various metrics, or we call it as rule occurrences. As you can see, for the validity, there are 4 metrics. This constitute 91% of the score. As we can see here at the bottom, each metrics could be seen. For validity category, 2 items here, there's 2 more items. These 4 scores will average to this score that is displayed here. You can also see the information about what is the latest trend. Has it been increased? Has it been decreased? That's the trend that you can see here. Likewise, for all other dimensions that you can see the information about the average score and also the individual latest score for each of those dimensions. Also on the right side, we can see information about how many metrics by the dimensions. For example, if I look at the validity, right, we already looked at, there are 4, the metrics have been defined. But again, after those 4 metrics, how are they looking like? I mean, are they all looking good? Are they okay? Are they too bad? For example, for the validity, one of the score is all good, like in 100%. Whereas for other ones, you see it's good, like it's within the limits. But whereas for the accuracy, it's marked as red, which is not within the defined limit, which is 80.67, which is not good as for the definition that we defined. But I'll show you how the definition came in. But before that, for example, if I want to drill down on one of these metric here, if I click on phone status here, I'll be able to see all the historical trend of that score. For example, I've already ran my the scorecard a number of times. As you can see, the individual score for each of those runs. There's not much deviation of the score, but this is the information that will be very useful, how the scores are changing for a given data set or a given data table. And then with that, you'll be able to understand whether the score is actually increasing or decreasing, and then you can take necessary action to improve the quality. And also, because this is linked to the cloud data governance, you'll be able to attach to your data elements. And in turn, they're actually associated back to your business glossary or all the data sets. I'm not showing you all the details here, but this is how you could attach the details to your data governance perspective. Coming back to the screen here, when I look at all the metrics information, I can see the latest score information, how many records have been processed, how many have been failed, what data element has it been applied to. And also, there's also information about what records have been failed and what records have been successful. I could go have a look at this preview of this data. When I click on this, it generates all the successful rows or valid rows. And similarly, for the failed rows, it gets me all the failed rows so that you know what data has failed the data quality checks. I'm not fetching all the records because it's going to take some time, because what happens is, like behind the scenes, it sends a query into the actual source data and fetch all the data and present it into the UI here. We're not storing any of this data, but it connects to the actual source and fetch the data. Now let me show you how these the metrics have been defined. So for example, if I click on one of this metric here, again, phone status, you can see there's a linkage to the actual, the profile that is actually produced all these scorecards. And also in turn, there's also a data quality rule that is applied to that. Let me show you how this is actually generated. Let me jump into the data quality service here. So here, if I look at the data quality service, we have data profiling and data quality. Now I'm opening on the data profiling service here. If I look at the data profiling here, there are a number of metrics that have been already defined. That is how my scorecard have been generated. If you look at here, if I click on this view scorecard, it will take me to the same page where I was in. But now let me show you, these are all the metrics that are defined. For example, the one that we're looking at, your phone email status, that is defined for the dimension completeness DQ dimension that was applied on these two input ports. And it is applied using a data quality rule called is there phone email information from a given contact information. But I'm going to show you how the rule can be defined. But before that, I'll quickly show you how to add this metric information. If you simply click on the plus here, and then if you go, all the available metrics information will be available based on the rules that you already added to your data profiling. For example, if I want to add to this one, I can go click and add information about it. This is where I was talking about all the information about the thresholds. So here, the users could configure information about the thresholds to qualify what is good, what is acceptable, what is not acceptable. And then user could modify those levels and then set the values accordingly. And how these metrics came in, it's all via the data quality rules that we already added to this data profiling. So these are the data quality rules, and some of the rules are regular data quality rules, and some of the data quality rules are actually used for measuring the data quality scores. So to add these data quality rules, simply go find your data quality rules and add to your data profile. So what you need to do is you just have to provide what input your data quality rule is actually taking. So just to take the input and then apply to that. Once you apply that, you'll be able to save and run your profiling task and then execute it, and it profiles the data. But before that, let me show you how to create that profiling task. So simply go here, click on profiling, and then give a name, location, and choose your data connection to your database table here. I have a flat file connection, and then here I have a number of data sets. I'm going to select one of the data set. Based on the data set selection, you'll be able to see all the data columns from the data. So you can pick and choose what columns you would like to profile to be able to understand what is the data distribution in your data table or data object, to be able to see how are the patterns, to be able to see how are there any null values or any blank values. Are there any what are the pattern distribution? All that information could be seen from this information. So you can pick and choose all the columns, or decide to choose specific columns. And once you decide what object, you'll be able to also see a preview of the data, first 10 rows of the data, so that you know what data you're actually working on, to see the format of the data. Is it in a acceptable condition or not? Otherwise, you can go format your data, or you can change your the data set itself in case if you're not looking at the correct data set. Also, you can apply some filters. For example, I have a data set which contains all the data for the worldwide. You might want to only profile the data that is only relevant to the Singapore, or maybe relevant to the USA. So you can write filters, and whatever the condition, maybe you can add your filter name. And then you can add condition. For example, you have a number of columns here, right? For example, I can choose a country, and then I'd say USA or Singapore, and you can add more conditions. And then that's how the filter is created. And then once the filter is created, you can enable this filter on your profile. So once the filter is applied, when the profiling is happening next time, this filter will be applied. Only the subset of the data which is qualified by this filter will be fetched and will be profiled. And then you can disable it if you don't want to. And then once you have this definition done, you're ready to run your profile. That gets the profiling statistics information for the database. I already have a profile ran already. I'm going to show you the profile matrix, how it looks like. This is my definition. I gave a name and location and the same data connection I was using and same data object. I've applied all the columns. I've created a filter. And then when I ran my profile, this is how it looks like. It gives me information about all the null values, distinct values, non-distinct values. and also information about the patterns. What is the minimum value, maximum value? What is the top pattern? And what are the number of blanks and the percent of the blanks? This information will be very useful to find out how is my data looking like. For example, looking at the number of nulls, I'll be able to identify is my data complete, or is my data having all the values or not? And also looking at the distinct values, it gives me information about, are there too many duplicate values, or all the values are unique or not? So that way, like, it gives me some information to look into my data just to find out data problems. So likewise, you can go have a look at all the columns that you already profiled from your data set. For example, like if I click on one of the column here on the right hand side, it gives me information about the trend chart, like based on the number of profiles. Each dot indicates a profile run. I have ran my profile already 5 times. That's where you see all the 5 dots here, 6 dots here. So it gives me a trend, like, there was no change until 5th one, but there was some change after the 6th run. Likewise, you see information for all the distinct and non-distinct. Also, you can see information about the data type. What was the original data type of this column, and also what is the data type of the data. For example, this one is matching with exactly the same as the string one what was defined. For example, if I go here to the string, the phone number, again the same format is available there. And also at the patterns, you'll be able to also at the patterns, you'll also be able to see, like, what is my pattern, how is it looking like, is it having is it having too many variations of the pattern, or is it okay, or is it acceptable as per the business. For example, here this is an email, so it's having information about 6 characters, 9 numbers, and then at the rate, and there's a 9 characters, and then again iPhone 9 characters, something like that. Likewise, if you look at the phone number here, there are the number of patterns here. Like, you see the numbers and other characters, numbers, other characters. Likewise, there's this is four digits, and then this is 4 digits. And we also have other information, like where there are lots of null values for the phone numbers. And also we have other patterns. So this information will give you information about what is the pattern my data having. Do I have to normalize the patterns, or do I have to take some action? That way, what action need to be taken care. And similarly, you can see what are the most frequently happening values in the data. So this is the list of top 5 values. And then you can drill down into each of this information and find out more details about that. What are the frequency of this one? And just in case, if you want to export any of these values as a reference data, you can always do that by simply clicking on this export option, and you can create a reference data. And then simply export it. So once I export it, it creates me a reference data dictionary. And then you can start playing with the dictionary in case if you want to apply and use that data in your data quality rules. I'm going to show you one of the examples how to use the data quality reference data or dictionary in a data quality rule. But before that, coming back to the summary here, at the bottom, you can also see the data preview information, and you can also apply queries to find out write various queries, like the filter that we just shown, right? When you can apply filters based on the column and also based on the data quality rules that you have already applied. Using that status information or the output information, you will be able to fetch some of the data, and then you will be able to say the information at the bottom pane here as a preview. If you apply query, you can also download the data to a flat file. And as one of the cool thing about the profiling aspect is that when it ran the profiling runs for a number of times, it'll be able to identify the number of issues automatically using our clear capabilities. So for a user to identify all these issues, it might take a long time to go through each and everything. So what we've done is, like, we have provided lots of algorithms where it will be able to find out completeness issues, validity issues, where in terms of the pattern variances, in terms of the value distribution issues, the maximum min value issues. It'll be able to automatically identify all the issues and provide the insights. These are all the insights that have been identified based on the number of the profile runs. Here you can see there's some change in terms of the column length, and also some change in terms of the date locally check, meaning it is not conforming to the specific date locally format. Likewise, there are a number of the suggestions have been provided. User can go and either accept that suggestion or reject that suggestion. If it is accepted, you can see it is already approved. One of them is rejected. So if I have approved it, a rule will be automatically created and will be applied to the profiling. Here, you see the naming convention RS is a underscore is actually suggested by our Clear engine. And that's how the rule has been created and automatically applied to this one. Next time when the profiling ran, it automatically applies to the profiling run. You can see here information about, so it already profiled using the rule, and then generated the what if scenarios. How would the metrics would change if I had applied this data quality rule versus the actual, the metrics on this parameter here or the column here. And then in case if the user rejects it, it doesn't do anything. It won't add any rule. But like it's up to the users to go find out all the suggested the insights, and they'll be able to find out and whether they can approve it or reject it or not. We looked at this metrics tab. Let me jump into the data quality rules and how to actually design these data quality rules. If I jump into this data quality tab, we have a number of artifacts that we can support creating the data quality rules. One is rule specification, which is helpful in define the data quality rules using simple if then else logic. Dictionary for maintaining the reference data dictionaries, all the reference data that you can use to apply in a data quality rule. Verifier to validate and enrich the address. Cleanse to cleanse the data, to standardize, remove, replace, and any uppercase, lowercase can be done using the cleanse operations. Deduplicate asset to actually perform the matching operation to find out any duplicates, and also consolidate and create a master record. To parse given a string of the data, you'll be able to parse the data into individual tokens. And not similarly, similar to the parse, the labeler will be able to parse out the tokens, and you can actually label the data. I'll quickly show you some of this in a demo. Firstly, let me start with the deduplicate, where we can identify. I have already created a deduplicate assets. How to create it? Simply click on the deduplicate. And what you do is basically define what data set you're actually working on. What are you trying to achieve? The deduplicate capability that we have enables you to identify duplicates for a given person, for a organizations or locations. So that's where you choose the various data objective here. So are you working with the contact? Are you working with the address? Are you working with the the organization? All this information could be selected from this given object information. And then index key could be used based on the objective that is selected. It offers you a number of index keys, which will be used for the matching operation. And that is how it improves the performance and all. And also you have data locally, where you can choose, pick and choose what data that you're working on. Here we can have we have number of countries information. You can pick and choose what country of the data that you're actually working with. We have also advanced options where you can actually tune your match performance, and we have various options to change it. If you select one of these options, they automatically select these the accuracy, confidence, and key level. But if you select the custom level, it allows you to change these levels of the matching process. And then you'll be able to define your threshold levels as well, just in case if you want to define your own thresholds. And for example, here I've already have a deduplicate asset configured for a person belonging to a United States of data. And then I'll process the data here. And then when I ran this, I have number of data here. For example, this guy here, Alan Moynan and Alan William Moynan, living at the same address, having the same phone number, has been classified into the same cluster. You see the cluster size, they have 2 records in the cluster 1. And likewise, there's another cluster 2, there are 3 records in it. So these 3 records have been classified into that. So it identified the duplicates and grouped them into clusters. And then now I can use my consolidation process actually to consolidate the data. So I've already applied some consolidation logic, field-based consolidation logic. Based on the records, duplicate records they have identified, I'm actually building a master record. How am I building a master record? Using the field-based the consolidation techniques. So whenever I see person name, look for the shortest name and then use that as a master record. For example, this one, this is the person name here, Alan Moynan and Alan William Moynan. So because this is the shortest, that has been used because that is what has been field-based logic has been defined. Likewise, you can define the strategy using all these field-based strategies, and then set your what are the strategy that you want to build your master record on. But otherwise, that's how a deduplicate asset identify all the duplicate records and cluster them, and then you can create a master record using the duplicate records. All right, moving on to the next the asset, which is a cleanse asset. Simply select the cleanse asset and it lands you here. You can give a name, location, and then in the definition, in the configuration page, what you do is like it offers you a step-based approach. What you want to do you want to convert the case, or do you want to remove the values, or do you want to remove spaces, or do you want to replace the values here? So here I have number of settings configured already. For example, removing values. For removing values, I'm giving information about what values do I want to remove from the given string. So I've given lots of values here to remove. And also, I want to show you one more here. Remove spaces. It allows you to remove leading and trailing spaces. And likewise, you can apply a number of configurations. I want to also show you how to apply replace values. You can replace values either using a dictionary. So you can pick and choose where is your reference data dictionary, and then you can add that. What it does is basically it looks into the dictionary information. I'm checking for some random dictionary here. What it basically does is like whenever I've given an input data, it goes checks in the dictionary. If there's a match found, then it returns what are the column that I've selected as a valid columns. For example, if there are a number of columns in your dictionary, in this case, there's only one column, it returns what are the column that is found the match on. And then that will be outputted here. So that is how you can configure the cleanse operation to actually remove or replace values, uppercase, and standardizing the values with the dictionary matches. There was some question here in the chart here. What is the use case to do deduplication and creation of master record in CDQ versus the master record creation in MDM? Yeah, then that's a good question. Yeah, I think the primary use case is MDM, but if you're doing your standalone use case for the data quality, be it for the data migration, data integration, or your modernization use cases, the deduplicate assets could be applied to your data integration pipeline. That's how it identifies any duplicates and creates some master records. So without having to use the MDM. Moving on, the business rules using if then else logic. So again, I've already created one rule logic here. It's fairly simple, simple if then else logic. What I do is I go here. It provides me information about like what logic I could create. If this specific input is not null, and this specific input is actually present in this dictionary. So how do I do that? I go here and go select the dictionary information. And you can pick and choose what dictionary based on your business requirement and select that. If it is present here, and I'm actually replacing with a specific content again from the dictionary using the dictionary. So that is how you can actually make use of the dictionary. And also it supports various other functions as well. For example, if I go here, it provides all the functions that are most widely used, like SQL functions, substring, finding a trim of the. So you have lots of functions here that you can make use of to apply on your input string. And similarly, you can, this is a simple logic. You can also build complex logic. So for example, you can build some child rules and then also attach to the parent rule. Your rule logic could get very complex. It depends on your business case. And also you can call rules from rules within rules. So you can build a rule and then also this rule could be called from another rule. That could be done using our capabilities to build the complex rules. And similarly, we have a labeler asset, something similar to cleanse, and then you can define a step-based approach. What you can do is you can define the logic using dictionary data, where you can look into specific dictionaries. If there is a match found, you can apply labels. Also, you can write regular expressions, and if there's a specific pattern is matched, you can output a label based on your the regular expression. For example, in this case, I've actually used one built-in regular expression. We provide number of regular expressions out of the box. You can see there's about 365 regular expressions that you can use to match any of the patterns, and then find out a specific label. For example, in this case, there's credit card, American Express credit card pattern, and that has been identified. And then a label has been put together here. So if you look at my test data here, I've given an input string with a credit card information, and that has been labeled as a credit card, American Express credit card. So likewise, if your input string has multiple tokens that matches your criteria, it also labels that as with the relevant label information. For example, Alberta is one of the Canadian province, and this is a American credit card number. And similarly, we also have the parse the asset. Same method again. Like you can define your logic using regular expressions or a dictionary. What I've done here is I've implemented a logic to actually parse out a product description information. Here you can see sample product information for HP AMD the processor. So I've used number of reference data dictionaries and custom regular expressions to actually parse out that information into what is the manufacturer, what is the product type, what is the model, memory capacity, and all. So that has been defined using all these simple logic using dictionaries. And for example, what is my dictionary? And what is my output? So whenever there is a find in the manufacturer dictionary, I'm going to output that value into my output manufacturer values. Similarly, for using regular expressions, user could build their own custom regular expression. They don't have to use a built-in regular expression that is provided by the Informatica, but you could write your own regular expressions. And there are other steps, like you can see again. The point here is that one of the dictionary that is out of the box that is provided by the Informatica. Informatica provides a bundle which contains lots of widely used rules and then reference data sets that you could make use of, so that you don't have to write your reference data from the scratch or rules from the scratch. I'm quickly show you how these bundles are actually are where you can find. If you log into the administrator page, there's a add-on bundle information. So there you can find various bundles, data quality, core bundle, for example. It has number of assets. You can see there's a cleanse assets. You can see dictionary information, for example, what are the cities of the world, and various colors, currency codes, and date, month information. All that commonly used values are readily made available in the bundles as dictionaries or rules or maplets. Maplets we call as the reusable the logic or package where you can make use of that rule and then apply it in your data integration pipeline. So now we've seen how to create rules, dictionaries, address verification. Oh, sorry, I forgot to show you the address verification. Address verification is fairly simple. You just open the address verification asset, and then you have to define what is the mode. Does your address have all the discrete fields, or does it have all that clubbed as a discrete fields and then line information, or is it available in multi-line? So based on the mode that you can choose, what is your input like? What is your address inputs are look like? Does it have organization? Does it have department? Does it have contact? All this information could be selected. For example, my configuration, it has an organization address line 1 and address line 2. It has a postal code and locality and a state information and a country information. Based on this input information, a verifier will process your address, and it will verify it and also enrich the some information. Again, you can add more information in the output. What would you like to add? Like, for example, you might want to add status code, you might want to add enriched information. Based on the country that you're working on, you can also add certified information, and then this will produce the relevant outputs accordingly and a standardized address. So what happens is, like, when you process the address verification, it has lots of country specific reference data files, which gets downloaded into your runtime, and then they make use of those reference files to verify your address and enrich the data. And these the country specific reference data need to be purchased when you purchase the data quality. And now we've seen all the data quality rules, and then now let me show you how to actually make use of these in the data integration pipeline that you're going to build. These are all the artifacts that we've seen so far, all design artifacts. They are reusable artifacts. They could be added to one or more data integration pipelines. It doesn't matter what kind of data set that you're working on. And then it can be applied to financial data. It can be applied to healthcare data. It can be applied to any other data, as long as you have a data integration pipeline, and then you can attach these data quality integration data quality checks into the integration pipeline. Let me show you how they look like. So based on the rules that I've defined there, I can create my mapping or a maplet. So here is a mapping that I've already created. You can see here, this is my source data. This is the rule specification, and this is my parse data set. And then I'm processing and applying some data quality checks, and also checking for the context status and all. Based on that information, I can actually write some routing logic. If all good, I want to send it to the target data database. If something wrong, I want to send it to some downstream database where somebody gonna review that bad data. And similarly, you could make use of the complex logic to apply deduplication checks, and the data coming from different sources. You can apply union, or your single source might have duplicate data, whatever the way it is, but you can apply duplicate checks, parse the data, and then you can find out what is the master record or what is the survivor record. And again, like, you want to apply some filtering criteria to write it to the good data target and bad data target. But the concept is that, like, you can apply your data quality checks in your integration pipeline before it actually sends to the target data from the source data.